let's copy the essential information for the final lesson, number 12. And I'm going to skip the graph for just a moment because I'm going to try to redraw it to the best of my artistic ability. Because sometimes I think getting the slope off a graph is easier. It depends on the numbers. All right, so again, we want to find a linear model. So I see linear model, I'm saying, okay, that's y equals mx plus b. But they're saying let the height be h. So instead of y, I'm going to use h. Instead of x, I'm going to use t. Okay, so I'm going to rewrite this as h equals mt plus b. And then it says use the following data. A 3-year-old boy is 100 centimeters. So that's like an x and a y. So, so if x equals 3, and then y equals 100. So that's 1 point on the graph. So we'll call that point 1. And then for a 14-year-old boy, their height would be 168 centimeters tall. That's a pretty good size 14-year-old boy. So this would be x equals 14, y equals 168. And so that can be our point 2. So they don't give us the slope, they don't give us the y-intercept, but we can calculate them with this information. So the first thing I would do is the slope. Formula for the slope is that y2 minus y1 over x2 minus x1. And so this is my second point, so that's the y value, 168, minus the other y value, 100. Divide by the second x value, which is 14, minus the first x value, which is 3. 168 minus 100, I'm pretty confident about that one in my head, but I'll double check on the calculator. 14 minus 3, and then I got to clean that up. All right, so that's my rough slope right there. Let's go to a calculator and double check. So Desmos is a pretty nice calculator for this. Let's get a new line because it's got the fraction button there. And so I can just type the 168 minus 100, arrow down to the denominator, 14 minus 3. And I get this wild decimal here, which Desmos will give me as a fraction 68 over 11, which is what I wrote in my paper too. So I can verify my arithmetic. And then I have the decimal version. Let's read the problem to figure out how they want us to round. Find the slope, round to the nearest tenth. Okay. So we would say to the nearest tenth, 0.62, or 6.2, excuse me. So let's make a note. This is about 6 point, and then it had a bunch of 1/8s repeating, which I'm going to say to the nearest tenth is 6.2. And a reminder, what do these numbers mean? The 68 is a centimeter change from a 3-year-old to a 14-year-old, and the 11 is years. So that number right there is centimeters per year. Okay. So what these 2 points predict is that the average boy will grow about 6.2 centimeters per year, which is like the width of my hand. No, not quite, less than that. I think the width of my hand is like 10 centimeters, yeah. Okay, so it's less than the width of my hand, a few fingers in height. So we have a slope, and again, your numbers may differ, but I think mine is 6.2 centimeters per year. The y-intercept's a bit more work, and let's go back. So at this point in my formula, I think that h is equal to about 6.2 times t plus b, and I need to know what is this b right here. All right, so to do that, we just pick one of these points to plug in. I'm going to go for the first one. So if t is 3, I'm going to plug that in, multiply it by the 6.2, and that's supposed to be equal a height of 100, and that will help us figure out what b is. Now I'm using the rounded version. It's usually safer to use a better version of the number, like the fractional version or the decimal version, to reduce rounding error. Otherwise, things won't quite check out. So I think I'm going to throw in some more decimals and then deal with rounding after. So instead, I'm going to scratch that. I'm going to call it 100, 6 point. I'm just going to throw a whole bunch of those 1/8s in there, maybe that many times the 3 to reduce my rounding error. So I need to multiply first and then subtract this over to the other side. So multiply and then subtract. So calculator time. And again, a lot of calculators have that previous answer button, so I could take advantage of that too. So let's do that. New line. Google and Desmos do this, as do most others. So I want to know what is 3 times that slope, which is my previous answer. And I get 18.54545455. And then we're going to subtract that to the other side. So let's write down what that is in the notes. So we're going to end up subtracting about 18.54545, oops, 545-ish, something like that on each side. Throw some dots there because I ran out of room. So I want 100 minus that number. Calculator, and that is my previous answer now, so I can just say what is 100 minus that number. And then I can round so I have less rounding error. Would it be a big deal in the end? We'll see in a sec. So I think the y-intercept to 1 decimal place is 81.5. Write that down. If I use that rounded 6.2, will it be too much different? Let's see. So that would have been 100 minus 6.2 times 3. I get 81.4. So I'm only 1/10 off. Will the computer freak out about that or not? Sometimes it will, sometimes it won't. 81 point, let's see, what was my last version? 5. That's the one I'm going to go with. And I can check this out to see if it's reasonable by checking out the other points. So I'm going to do a quick check just to show you how. We did this once before, maybe twice. It was a long time ago. So I'm just going to check my equation with the other points. So the other point was 14,168. So I want to see if that works. I think my equation is h equals 6.2 t plus 81.5. If I plug in 14 here, I hope the answer is about 168. So what happens when I take 6.2 times 14 and add 81.5? Hopefully it's about 168. Question, I don't know, let's look. Calculator, 6.2 times 14 plus 81.5, 168.3. So I'm close enough because we have 2 bits of rounding error. We have a little rounding error going on with the slope and a little rounding error with the y-intercept that compounded to be 0.3 centimeters off of what it should have been. Best we can do. Those are the directions. All right, so my linear model used the right letters, and here they're prompting me to use h and t, not x and y. So h equals 6.2 t or times t plus 81.5. And then we want to use this to predict or estimate the height of a 13-year-old boy. So we're just going to plug in 13, see what we get. And then we want to estimate the age of a boy is 107 centimeters tall. So plug in h equals 107, solve for t. So the part E is aside from, say, finding the y-intercept, is probably the hardest part, the part E. So I think you guys can finish up that one on your own, pretty straightforward. We got a few minutes left. I think I'm going to stop on that one and start a new problem unless there's a question here. Looks like there's no questions at the moment, so let's look at another one to get started. I was thinking number 13 was the one I wanted to get started. '19, we could look at 19 next class. Yeah, I'm gonna go with starting number 13. All right, so yours will be similar, if not the same, on this one. Let's copy this into a new screen or pick it apart. Okay, so I'm just going to get it set up. I'm not going to finish it. Delilah wants to join a gym. So she shops around to find the one with the lowest overall price. She's not sure how long she'll be a member. She finds the Harbor Square Athletic Club is running a special and only charges $25 for initiation fee plus $87 per month. She's got to pay $25 up front and then every month another $87. The local YMCA charges $100 to join, but it has a monthly fee of $72. So they charge more up front, but less per month. So looking at this right here, and then what is our objective here? To find equations for linear models. So we're given the linear models. I just have to figure out which numbers are slopes and which are y-intercepts. So looking at that, I would say this initiation is like a starting amount. So that would be a B for the y-intercept. Same thing here, $100 for join, that's a starting amount. Right, start at, that's our B for that one. And then $87 a month, I think it'd be better to say $87 per month. It's more proper language there. And this one is, monthly fee, so that would be $72 per month. So those would be the slopes. So this right here is a M, a slope, and this right here is another M. So for the athletic club, the Harbor Square Athletic Club, it looks like if C, we're using C instead of Y and M instead of X, it would be C equals 87 per month, so 87 times M, right, M instead of X here, plus 25. And then the YMCA, it says use a C also for all the costs. So C equals, that one was a monthly fee of 72, so 72M, that's our slope, starting at $100. Right? So I think that was the hardest part, reading it and deciphering how to write those equations. So those are my two equations there. The next part of this one was under what conditions would it be less expensive to join the YMCA? Because at first the YMCA is more expensive, but since they're charging less per month, sometime down the road, the YMCA should be a little bit cheaper. And so we could either make a spreadsheet or solve an equation. So what I would do to answer part B, when is the Y cheaper, is we just set these two equal to each other and find where they're about the same, and then the Y will be cheaper after because it starts off more expensive, right? Starts, oops, wrong order, more expensive, but it's cheaper per month. This one is growing faster, the athletic club, because it's growing at $87 a month, your total cost. So I would just solve setting those two equal. So take the YMCA, 72M plus 100, set it equal to 87M plus 25, and figure out what month that happens at. And that's the turning point where the Y suddenly becomes cheaper. Okay, so let's do that. We've got a couple more minutes here. To solve this, I would do what first? I think I would move this 100 over to the other side. Then I get negative numbers. Sometimes I don't like negatives. So I'm going to move the 25. I changed my mind. Let's subtract 25 to the other side. And again, since the 25 does not have an m, it can only be combined with the 100, which doesn't have an m. So we're going to keep what are called like terms together. So 100 minus 25 is 75. 72m plus 75 now equals 87m. Since I brought the 25 to the left, I'm going to take that 72m and take it over to the right. So then I'm going to subtract 72 months, or 72 times the month, to the other side. And so that becomes nothing, leaving just the 75. And then 87 minus 72 is 15, I think. Let's double check my calculator. That looks right. 87 minus 72. Yep. All right. And then the last step is just divide by 15. And I'm going to guess 15 goes into there 5 times, but I'm positive. So 75 divided by 15, yeah, 5 times. Okay. There we go. So again, I have 15 divided by 15, which is 1. 1 times m is just m. Let's go over this way. And then 75 over 15 is 5. So it looks like at 5 months, they will be the same cost. Okay? So if I were gonna like kind of draw a picture of what this kind of looks like, let's see, if this is $100, no, let's put $100 right here. So that would be $200 there. The red is the athletic club, starts at 87, which is maybe about right here, and then starts heading up. And then in blue, the YMCA starts at 100 right here, but it doesn't go up as fast. It's slightly less steep. So that one would look like that. And they meet here 5 months later. So for the first 5 months, the athletic club is cheaper. Exactly 5 months later, they're exactly the same. So it doesn't matter cost-wise, 5 months later, they're identical. And then after that, it turns out the YMCA is cheaper. So when is the Y cheaper? Answer would be after 5 months. So probably 6 months or more would be a good answer for that, because you probably have to pay for a full month up front. And the only way to check that is to plug in some numbers to see. So that would be the next thing I would do. We're running out of time here, so I'll leave it up to you to check that result. So let's see, under what conditions would it be less expensive to join the Y? The YMCA is less expensive if she remains a member for more than 5 months. Because at 5 months, they're the same, would be my answer there.